Hi everyone, welcome again to another video of the series SAT Math Explained. Today our focus skill will be linear inequalities in one or two variables. This is our last focus skill of the algebra domain. I've uploaded the videos for all the previous ones. And after this we're going to move on to the advanced math domain and all the focus skills in it. Then we'll go to problem solving, then finally we'll go to geometry. I'm just doing it in the order that College Board has it in. And all of these videos will be uploaded by the end of the month. By the end of July. Because I do upload daily, so if you guys want, you can subscribe, like, and click the bell to support, and so that you guys know when I upload. So, let's get started. So, what do you guys need to know? Oh, and by the way, this focus skill specifically, it's one for me, I think it's one of the easiest because unlike the other questions, if you guys watch, the questions always vary. Like when we're doing the examples, there's like many different types of questions you can get. This one, there's literally only like 2 or 3 types of questions, and most of them are similar. So let's get started. So to solve these questions, you need to know the symbols and words associated with them. So basically, there's you guys know the greater than, less than, greater than, equal to, less than or equal to symbols, and then you need to know which words are associated with it or which phrases. So there's something like less than or greater than. What does that correlate with? So there's this very good table I found from Khan Academy. If you guys want to take a moment and look at it. It just gives you like the phrase, and then it just tells you what it translates to. So like no less than C is greater than or equal to. If you have like at least, stuff like that, it just gives you the phrase and it tells you what it translates to. So if you guys want, you can pause the video and take a look at it. So this kind of goes hand in hand with what to know number one. You need to know how to interpret word problems, which is mostly going to be by knowing what these mean. Knowing what these means and being able to maybe write an equation, maybe solve for a variable, maybe something like that. You also need to know how to interpret equations and their graphs. So you might get an equation. Mostly, it's gonna be you're gonna have to give them an equation. So you still have to understand the equations, and they're linear, so it's gonna be in the form y equals mx plus b most of the times. And you just need to know how to either make them, which is gonna be the most likely case, or sometimes you're gonna need to like understand it and like solve for something. Like it's gonna give you an inequality, and you have to tell them which coordinate is part of it, which coordinate is a solution. And so for their graphs part, you just need to know this. So if it's y is greater than, the line, the shaded area is going to be above the line. So like just look at like the y-axis, the shaded area is going to be above it. And then if it's less than, the shaded area is going to be below it. It's also great to know that dashed line means does not include, and then the dashed line is, or the solid line means that it includes. So y is less than, y is greater than, that is a dashed line. Y is less than or equal to, greater than or equal to will be a solid line. So that's really all you need to know about it. And then just know how to use Desmos. In one of the examples, I'm going to go over it. But basically in Desmos, it helps a lot if you know how to graph these. Because like you're here, you can like graph it and you can like find the solution. Like let's say they ask you for a bunch of coordinates, which is gonna be they're gonna give you a bunch of coordinates and they're gonna ask you which one is a solution to the following equation. And the equation is gonna be not equation, inequality. And then you can just plug in the equation and you can just see which points are in, which points are not. And Desmos will shade it in and everything for you. So that's really it for what you need to know. It's very simple for this video. And so let's move on to how to solve. So for how to solve is also very basic. Just use what you know, like these things and what you know from the previous videos. Just see what the question is asking for. What does it want? Does it want the equation? Does it want does it want an equation? Does it want a graph? Does it want a solution? Just see what it's asking for. And most of the times, it's just going to be to use Desmos or make an equation based on a scenario. Or sometimes there's going to be not interpret a graph, but you can use a graph to interpret the question. So just use Desmos. But yeah, so let's just move on to the examples. So these are the easy examples. First thing, as we do every time, we do 2, 2, 1. So 2 easy questions, 2 medium questions, and a hard question. So I do recommend that you guys do try and solve the question on your own first, because you don't learn from me if you just watch me explain an answer. You're not learning anything. You're just giving yourself like a false sense of understanding. So I do recommend that you guys solve, then watch my explanation. So the first question tells us that a bakery sells trays of cookies. Each tray contains at least 50 cookies, but no more than 60. Which of the following could be the total number of cookies on 4 trays of cookies? Okay, so we're told that on each tray, so one tray, you can have at least 50 cookies and no more than 60. So at least 50 cookies, if you go back to our chart, at least is, okay, it's not here, but like least, it means the smallest value that satisfies the inequality. So it has to be included. And the same thing for no more than. No more than is also included. So they're both included. See, so that helps a lot. So then let's say that the number of cookies is x. So x is greater than or equal to, because it's at the least. So 50. And then it is less than or equal to, because no more than 60. So it can't be more than 60, but it can be exactly 60. And then it asks us, what is the total number of cookies on 4 trays of cookies? What is the total number of cookies on 4 trays of cookies? So here x, I'm sorry, I think I said that x was the number of cookies. X is the number of trays. So one tray, this is 1 times x. So one tray can have between 50 and 60 cookies. So if you want how many cookies can 4 trays have, so we just go from x to 4x. We go from 1 tray to 4 trays if x is trays. So if we want to multiply this by 4, we just multiply this by 4 times 4 and this by 4. So the whole inequality is multiplied by 4. And you can use Desmos for this. You get 200 is less than or equal to x, which is less than or equal to 240. So then let's just go back and make sure, what is the question asking for? Which of the following could be the total number of cookies on 4 trays of cookies? So for it to be the total number of cookies on the 4 trays, it has to be a number within this. So 165, that is too low. 165 is too low. 245 is above, so it's too high. 285 is also too high. Then you just see 205 is between 200 and 240. So that is the answer. It's very simple. So let's move on. And again, if you guys have any questions, you can just let me know in the comments. So this one says, which of the following ordered pairs x, y satisfies the inequality 5x minus 3y is less than 4? 1 is coordinate 1, 1, 2 is 2, 5, 3 is 3, 2. So for this question, you can very easily just use Desmos, which I'm going to show you guys how to do right now. Okay, so I pulled up Desmos, and sorry, let me get it open. Okay, so right now, just start by, if you want to use Desmos, start by just graphing the inequality. And so 5x minus 3y is less than 4. And also, just so you guys know, if you ever want to put like a less than or equal or greater than or equal, you just put the shift comma or shift period that gives you these symbols. And if you put the equal sign after it, it just adds the line. That's important to know for the Desmos. So okay, so 5x minus 3y is less than 4. So then you see it gives you the thing and it highlights it. It's greater than, 5x minus 3y is less than 4. But then when you solve for y, it's going to be greater than. And so then it shows you that it's going to be like that. That is the part that everything in this red area is a solution. So then what do? We can just plot these points, just exactly how they're written. So 1, 1. And then 2, 2, 5. And then 3, 2. Sorry, you need parentheses. Make sure that you put parentheses. And then 3, 2. Then you just go to your thing and you go to and look which ones are on this. So the purple one, there's a purple one and a green one. They're both on that. So it's 2, 5, 1, 1. The black one is outside the shaded area. So that means that it's not a solution, or it does not satisfy the inequality. So you just plug them in. So 2, 5, that is 2. And then 1, 1 is 1. So it's 1 and 2. So another way to do it, you could technically just plug these points in. And if you plug them in, it would be true for all of them except for the last one. But that would take time, and like you could do it. Like I'll just do one example. So let's say you want to check 1, 1. So you just do 5 times 1 minus 3 times 1 and then a equals 2, and then that has to be less than 4. You know, it's less than 4. 2 is less than 4. So 1 is the solution. But it's much quicker. Honestly, it depends on preference, but for me, I think that just using Desmos is a lot quicker than plugging all the points in. Okay, so now let us move on to the medium questions. So this question tells us that a cargo helicopter delivers only 100-pound packages and 120 packages. So there's only 100 pounds and only 120 pound packages. For each delivery trip, the helicopter must carry at least 10 packages. So at least means greater than or equal to. And the total weight of the package can be at most 1,100 pounds. So that means at most means that it must be less than or equal to. So what is the maximum number of 120-pound packages that the helicopter can carry per trip? So this one we could solve it using just basic math, but I'm going to show you guys how to solve it using inequality. So basically, let's just assume that the 100-pound packages are x, and then the 120-pound packages are y. So you have 100x, so 100 times the number of 100-pound packages, plus 120. So the number of 120-pound packages times 120. So this gives us the weight, and that must be so it can be at most 1,100 pounds. So this must be less than or equal to 1,100. And then at the same time, there's two constraints. The other one says that the helicopter must carry at least 10 packages. So that would tell you that x plus y, so the number of 100-pound packages, plus the number of plus y, the number of 120-pound packages, must be greater than or equal to 10. So now you can just treat the inequality as an equal sign for now and just solve it using the same things you've learned in, I think it was solving linear inequalities 2 variable. That was like the second video of the series. And another way is to just use Desmos. So you could like technically solve it and do like a system. Oh yeah, it was the system of inequalities video. So you could technically do the system of inequality use elimination or substitution, but easier way would be to just graph it. So if you were to just graph it, just give me a minute. Let me pull up Desmos. Does that show up correctly for you guys? Okay, the whiteboard. Okay, let me just fix it. Okay, so I finally got it to work. So basically, you could just plug in the same thing we did for the last question, but now there's 2. So just put 100x plus 120y. Just write the equations that we made. Less than, and you put shift comma to get less than, and then put the equal sign to get less than or equal to 1,100. And then x plus y is greater than or equal to 10. So now you can see, where do these overlap? These overlap here in this area. And so it asks, what is the maximum number of 120-pound packages that the helicopter can carry? So the maximum number tells us, so we want the highest number, and 120-pound package is the y. So at what point is y the highest? So y is the highest at here. So right here, though, you see that this shaded part is the part where it's a solution that is possible using the 2 lines. And then we just go to the highest point, which is right here. Because they're both solid lines, this is the highest point, because they're both including. So 5, 5 would be the highest point, and the y, because we're looking for the maximum number of 120-pound packages, so the maximum number would be 5. I hope that makes sense. So the answer would be 5. Now, let's move on to the next one. Let me just make it bigger. Full screen. Okay. So for this one, it tells us that in North America, the standard width of a parking space is at least tells us, so greater than or equal to 7.5 feet, and no more than, so this is less than or equal to, than 9 feet. A restaurant owner recently resurfaced the restaurant's parking lot and wants to determine the number of parking spaces in the parking lot that could be placed perpendicular to a curb that is 135 feet long. So all this is honestly is really just extra information that's just going to confuse you. So you just need to know that it's 135 feet long on the standard width, based on the standard width of a parking space, which is following describes all the possible values of n. So if he has a 135 foot long, what's it called, parking lot, and he wants to know how many parking spaces he can put. So to make an inequality, just look at the minimum he can make, and then look at the maximum. So the minimum, look at the maximum parking space he can make and the minimum parking space he can make. So to find the maximum parking spaces that he can make, you want each parking space to be as small as possible. So 7.5 feet. So you just do 135 divided by 7.5, and this should give you the number of parking spaces he can get if each one is 7.5. So I'm just going to use Desmos, and 135 divided by 7.5, it gives me 18. So the biggest possible number of parking spots is 18. So we know that the answer is going to be D, because that's the only one that says that the max is 18. But let's just make sure by finding the minimum. So by finding the minimum, you assume that each parking spot is the biggest possible. So let's assume each parking spot is 9 feet. So I'll just put that into Desmos law. So 135 divided by 9, and I get 15. So I put 135 divided by 9 on Desmos, it gives me 15. So then I know that n, the total possible number of parking spots, has to be either greater than or equal to 15, because we're told at least, or less than or equal to 18, because we are told at most. So that would be answer D. And then finally, let's just move on to the hard question. Oh, my face isn't showing. Let me just put it on top. Okay. So now to the hard question. It would be best if you guys try it before you watch my explanation. So the hard question tells us that a local transit company sells a monthly pass for $95. So a monthly pass is sold for $95, and it allows an unlimited number of trips at any length. Tickets for individual trips costs are 1.5, 2.5, or 3.5, depending on the length. So what is the minimum number? So we want the minimum number of trips per month, for which a monthly pass, which was $95, could cost less than purchasing individual tickets for trips. So we want 95, the cost of a monthly pass, to cost less than purchasing individual tickets for the trips. So right here, you need to use the skills that you know, but also you need to use like some like logic, because it tells you it wants the minimum number of trips per month. So the minimum number of trips per month to add up to cost more than 95, you would have to assume that every single trip was the most expensive. So then you put 3.5, and let's say X is the number of trips. So now we want to solve for what is the minimum number of trips per month that this 95 would be less. So then just divide both sides by 3.5 divided by 3.5. Then I'm just going to put this into Desmos. 95 divided by 3.5. 95 divided by 3.5. 95 divided by 3.5 gives me 27.142. So you get X is greater than 27.14, let's say. So right here, you might want to just go ahead and type in 27.14, but that would be wrong, because in word problems, you have to put it into realistic. So the minimum number of trips, you can't take 0.14 of a trip. You have to take a full trip. So for it to be the minimum, you would have to go the next whole number greater than 27.14. So that would be X equals 28 is the minimum number of trips. $28. So this is something I didn't include in any of the examples, it just wasn't in them. But an important thing to note is when solving inequalities is, let's say I have like 5x, negative 5x equals let's say 20. So right here to solve for x, not equals to, it would have to be let's say an inequality. Let's say negative 5x is greater than 2. So 20. I want to divide both sides by negative 5. So you might say, okay, so x is greater than negative 4. But there's a rule in this: if you divide by a negative, you have to flip the inequality. So you would actually get the actual answer would be x is less than negative 4, because you divided by a negative. And an important something to note: don't mix that up. If I had like negative 20 if I had like negative 20 is greater than 5x, dividing a negative, that does not count. This would still be x is greater than negative 4. It only counts if you divide by a negative. So this number, the number you put on the denominator is a negative. That is the only place that it counts. So I hope that is clear. So that is the end of our video. And just to remind you guys again, this is the final video of the algebra domain. And tomorrow, I hope I will start uploading about advanced math, and then problem solving and data analysis, and then final geometry. And the whole series for SAT Math Explained should be finished by the end of the month, by the end of July. And yeah, that's it. So thank you for watching, and please consider subscribing, liking, and clicking the bell so you guys know when I upload. And bye.